let's see an example. This example is very important to understand the concept of information at an instant while something is in process of happening. So example is very simple, that how rapidly with the flow level, with rapidly the fluid level inside of vertical cylinder tank will be dropped if we pump at the rate of 3000 liters per minute. Okay, it's very simple. Okay, we need to determine the rate of fluid, okay, level which is dropping due to any rupture or due to any reason. Okay, due to any reason that cylinder is damaged and fluid is leaking out of the cylinder. Though position of a cylinder is kind of a vertical cylinder position is a vertical, but due to any leakage or opening of tap, the fluid is dropping out from it. And if we pump, okay, at the rate of 3000 liters per minute, how rapidly, okay, how rapidly, this is the question statement, how rapidly the fluid level of inside of vertical cylinder tank will be dropped, that is, okay, decreased. Here the concept of drop will be decreased. So let's consider see the first, okay, make a model of a tank here. For example, this is a vertical tank. And inside of this is a fluid. Okay, so the height of this tank, you can say the total height, if for example it's the center point of this, and of course the height is simply nominated here with small letter h, and there is a, okay, you can say just tap. So water is dropping off. Okay, the pump, okay, you can say that it is given here. Remember one thing, it is, that is all the statement is telling us 3000 liters per minute. That is, something is changing, and this changing is given in liter per minute. And if I am asking to you that the unit, okay, we should also familiar with the system, international units or other mathematical thing for understanding the concept of real world problem, to make a model or for computing algorithm. So what is this? Is a little as a unit in. Sometimes we are measuring the things in kilogram, sometimes liters. So we should know how to transform from one unit to another. Here minutes are in a standard way. We are measuring the thing in a second. Time unit is meter per second or something like. We should familiar. But here it is given kind of a rate of change. Rate of change is kind of a volumetric volume rate. This is the volume of a liquid. Volume of a liquid. And of course, this volume of a liquid, definitely cylinder is not kind of a 2D shape. It is kind of a 3D shape, and 3D shape, okay, is of course, for example, this is a circle. This is a circle, and if there are too many circles, and if we connect all the circles, then of course this will become, okay, some kind of a volume. Okay, if I remove the center portion or just the top one, the lower one, so I can say it's the kind of a volume cylinder. Okay, so initially the circle radius is given pi r square, but third side is also there, so you can say pi r square or somewhere, of course, height h. So this is the area of a bottom or area of a top, pi r square, so it will multiply with the height pi r square h, and it will become volume. Remember, okay, it is just similar like this. If you have a concept, for example, this is the x square, okay, x height, x width. So if there are too many x, so this side is also kind of x. So length, this is now it's a width, or you can say that vertical or base. So x multiply x, it will give you the volume of a box. Okay, so volume of a box, or you can say that it is look like this box is look like this. So you have this a box. Are you getting it? So similar, like cylinder is forming by too many concentric circles are connected to one another, and this too many circles are attaining some height. So this volume of a cylinder. Okay, everything you need to define. You should know how to make a formulae. Okay, how to design the mathematical concept by observing any given information or any real life problem. Okay, so if someone is talking about some irregular shape pattern of a pot or some container, then you should know how many things are involved there, and how you can determine its volume, or its one dimension, two-dimensional shape, three-dimensional shape. So they are talking about the fluid inside of a cylinder. Then of course we should know the volume of a cylinder. Okay, it's all three dimension. So now this is the volume, and they are telling us that the liquid rate, okay, if we pump at the rate means it is changing. What changing? Volume is changing. Volume is changing what? With respect to time. Okay, so it's liter are changing with respect to minute. So you are in this situation, we say it is given that dV, our you can say T equivalent to 3000 liter per minute. But one thing is very technical here. It is not okay dropped here. So they are using the word drop. Okay, very triggering word. Okay, if someone is approaching to you for making a computing algorithm, so he will tell you a story. It's your job to understand it technically. Okay, drop. You use the word drop. Okay, so you should use here negative sign. Though there is the company manager or some local vendor will not tell you the negative sign about these things. Your common sense should work. Okay, this is the mathematics. So negative sign. This is rate of change of volume. The drop okay, negative. Once it's dropping, increasing something else, okay, then of course you don't need to write anything here, no negative. But once it is dropping, so you must need to mention negative, okay. So with this value, okay, let's come to the point. As the time is passing, okay, time is passing, okay, so the radius remains constant. See, if the level at this point, after some time it will, but again radius, okay, from this point to this point it is constant. Radius here constant till the bottom of the cylinder. Radius will not change. Radius is constant thing. So your radius will not be affected. So your basic equation. So here the volume, your volume, okay, volume will be given, okay, for a given cylinder, and this statement is telling, okay, first we need to transform this liter into the cubic meter. So with respect to unit, some you can say that you want to transform this unit into, in System International, cubic meter is mentioned instead of the liter. So your 1 liter is equivalent to what? How many? Okay, here let me first see the concept of this, that simply, as I told you, that volume of a concentric cylinder can be given pi r square h. Here it's 1, okay, multiplicative identity, but if it is given in the liter, you want to apply the standard system, then you want to transform it into the cubic, cubic meter into the liter. So 1000 cubic, okay, or you can say that equal to 1 liter. Okay, now we will change this 1 equal to 1000. So V equal to 1000 pi r square h. Now you transformed your volume into cubic meter instead of a liter. So take the derivative of this with respect to time, dV over dt. So you have this is a constant as it is, and pi constant. R is what? As I told you, R is the radius. R is the radius. It does not change. Okay. Remember one thing. Remember, as I told, from top to bottom it is same constant. Somewhere we are considering the area directly proportional to the radius. Okay. Once it's a circle. Circle are changing somewhere. Okay. Its shape is changing. But here it is talking about a cylinder. Cylinder radius is from top to bottom is a constant thing. Okay. So changing is height is changing. Height. Remember. Okay. Here. Height is changing, okay, height is changing, level of height is changing, dropping of the fluid. So you should differentiate it with respect to time. Now you have this formation. It's very simple. It is already given to you. Okay, and substitute the value of this into this equation, because what you need to know, you know how rapidly, okay, the word is very important, okay, in start, how rapidly, my children, important thing, okay, keep in mind, how rapidly, this is the question mark, okay, no one will tell you, you should, okay, explore the information technically. So how rapidly, it means that how height is decreasing, okay, with respect to time. How rapidly, it means you need to know value of this. You need to know the value of this. So dh over dt, height with respect to time, change in height with respect to time. So by cross multiplication we have, and in the denominator there is 1000 pi r square, and of course, okay, what we did, we basically substitute the value here, okay, we substitute the value of 3000, okay, value of 3000. So, and on the cross multiplication, pi r square go into denominator, this 1000 go into denominator, minus 3000 here. So minus 3000, this one cancelled out. Okay, so your answer is what? Minus 3 over pi. Okay, that is your answer in cubic meter per minute. Furthermore, you can also transform this how rapidly, centimeter or whatsoever, it's up to you, okay? Hopefully understand, you got it, that this, all the things, okay, again go to the statement, how rapidly the fluid level inside of a vertical cylinder tank will be dropped. Fluid inside of a vertical cylinder tank will be dropped if we pump, or okay, if we open the tap at the rate of from this, okay, this tap, fluid is opening, fluid is leaving to 3000 liter, okay, per minute, kind of a big tank, okay. For clinic purpose you may open it for certain reason. So my children, how rapidly you need to, first you need to know, formulate the volume by considering the radius as a constant thing, and then you need to know, you need to determine this change of height in a cylinder with respect to time, okay. Also you can consider the unit transformation, okay, even you can keep the unit liter per minute, but it is just another thing that for knowledge based economy I told you that how you can transform it. Thank you.